Our next speaker is from AVIO AERO. AVIO AERO is involved with additive manufacturing in the aero engine business. He is the Additive Design and Technologies Manager. Paolo Calza is the Manager of Additive Design. His team mission is to provide support and leadership for the additive technology, proper usage, and spreading. Ladies and gentlemen, please welcome to the podium, Paolo Calza.
Hello, good morning. So I will start strong, so mentioning Michelangelo. So for Michelangelo, let's say sculpture is the art of removing to reveal all that is contained in the block of marble, right? Additive manufacturing is the opposite. So it's really a revolution for the design, also for the art. It's a new way of doing this stuff. I work for AVIO AERO, that is a G aviation business. We have a strong presence in Europe, and we are really working tightly for what regard additive manufacturing. So within G aviation in Europe, we have an initiative called Federated Europe, where we are trying to, let's say, organize ourselves in order to push forward the additive logic. Please note that in Europe we have also G Additive, so Concept Laser and also Arcam that are part of G and represent a really important companies for what regard for what regard additive manufacturing evolution within Europe. If I look at the G Aviation, we have different plants spread all around the world. Our headquarters is in Cincinnati, so it's ATC, Additive Technology Center. We have three main production sites. One is in Auburn, where we produce the LEAP fuel node. Then we have in Cameri, in Italy, another plant which is producing the G9X titanium aluminide blades. I bring a couple of blades with me, so you can have a look on the stage. And then we have the Brindisi plant that is going to be open, is going to produce the additive manufacturing parts of the new engines that we have designed here in Europe called Catalyst. Then we have two Lean Lab. One is ATC, and the other one is a Turing Additive Laboratory. That is where we develop parts and we industrialize parts before moving to the production sites. So, as I mentioned before, in G, we have really all the capabilities to know the process of additive manufacturing, because within the same corporate, we have business that are working producing powders, business that are working producing the machines, and then we are, as G Aviation, final user in, let's say, leveraging on all these assets in order to produce the parts. So that's really a key for us in getting understanding all the aspects of additive manufacturing by knowing all the full process. Okay, what our vision in leveraging of additive manufacturing? So we have our stakeholders that are mainly our customers, our let's say Boeing, Airbus, and so on, who is building the aircraft. And they are asking us for some challenges, for some needs that are linked to the availability of the assets. So they want to have really robust products, of course. They want to have really efficient products. They want to have eco-friendly products with reduced inspectability and also reduce unexpected maintenance. Those are, let's say, the key elements on which we want to build our products, our engines. And to do that, also, we try to apply some technologies in order to differentiate our product from the other competitors. One of these technology is additive manufacturing. So what is the advantage for us in using additive manufacturing? Mainly in three different aspects. The first one is really easy. We are going to redesign additive parts in order to make it lighter, to make it cheaper, to improve the performance of the component. This can be done, of course, because additive manufacturing, with additive manufacturing, we can create geometries that are more complex, and maybe we can create components that with higher performance. Improve quality. This seems to be, let's say, a nonsense for a new technology, but there are cases on which we are applying additive manufacturing, for instance, the EBM technology for TL blades, and we can have a better yield on production of the parts, a better quality of the parts. And of course, also we can use additive manufacturing in order to improve the design iteration. We can make some prototypes. We can see if a design, a geometry is worth or not. So that is also really important to improve the quality of the design. The third one that is the most important is, let's say, coming up in the recent time. We can try to, let's say, optimize the systems instead of the single components. So machines are becoming bigger and bigger, and we can print larger parts, right? So the opportunities are becoming larger because we can, instead of redesigning the single component, we can redesign a system. So we can put together different parts that at the beginning were considered to be assembled in a subsystem instead of having one single part, okay? So our history, let's say, in additive manufacturing is really well dated. I started to work in AVIO AERO in 2006, and as a stress engineer in 2007, I started to work on the first prototypes on titanium alumini blades made by additive manufacturing. I was checking the stress resistance of those parts with several component tests. And we are about to launch the production right now. So to get where we are right now, it takes a lot of time. It takes more than 10 years, and passing through several steps. So that to say that it's not really easy to the jump to make the prototype and then launch a serious production of the parts. There is a lot of behind that. As you can see on the top, several components have been developed and launched on the production. The last but not least will be the advanced turboprop, that is the catalyst engine that we have been designed and is going to be produced in the Brindisi plant. That will become possible because we have a larger machine, so we can print a really large part of the engine. On the bottom, you can see the aggressive, let's say, strategy that GE has made along the years for the infrastructure. So he bought several key competitors in the market in order to get the technology, like Concept Laser and Arcam in 2016. Okay, so what represents additive manufacturing for us? This is our new foundry that is clean, is with a green concept, with the low emission. We can also use the powder several times instead of just one, so there is less scrap material. We use when there is a cost benefit, so we really need to have a complex part to be printed to get this benefit instead of, let's say, traditional manufacturing technology. We started step by step, so our first part that has been qualified for the flight is the LEAP fuel nozzle. As you can see, it's really impressive. Instead of having 20 parts, we have just one part, really complex parts. We have 25% of weight reduction because we can remove all the flanges of the bolts, all the stuff that are required for the part. And we have this part is more durable, 5 times more than with respect to the conventional one. We have a series production ongoing, so 40,000 parts per year. It's not a small production. And similar condition we have for the titanium aluminized blades. Those parts are more loaded because those parts are let's say, spinning around at around 5,500 RPM with a pull load that is 20 tons, like a truck, at more than 600 degrees. So it's a really loaded part from also the mechanical standpoint. And so this is a following step with respect to the fuel lip node. To go to the additive system, that is the catalyst one, as I said before, we have really saved a lot of part count, and we were enabled to create this engine architecture in order to be more aggressive in terms of fuel burn and emissions. So, as I said before, this technology is really disruptive. We are just at the beginning. It's stretching all the system, it's stretching all the process. So to get the part done is not just printing. You have a lot of post-processing to do. You have the material to be produced. You have the powder and so on. So we can go through all the single block, but we don't have time. But just to say that each of this single part of the process in getting the additive manufacturing part is really, let's say, stretched by this revolution, because, for instance, if I look at the inspection, I can really print a difficult part with complex geometry, with complex internal geometry, but then I have to find a way to inspect the part in order to clear it before mounting on an engine. So that is somehow bringing critical aspects in the supply chain of this technology. This is not only linked to the single blocks, but it's also linked to the system. So the quality system is changing, the regulation, the standards are changing, because the technology will let's say, will allow to enter different aspects that need to be standardized or need to be regulated. The same way for the people. People are really stretched in the additive manufacturing because this is a really different technology. Also designing a part, you have a really white paper, so you have to create a mindset to be able to design the part with this new technology. The same for the supply chain, the service, repair. If you are really complex part to print, you have to repair, let's say, that's also an issue, because you have to deal how to repair that part. So everything is really complicated, and it's really complicated anche the way, let's say, we are interacting with the supply chain. You need really a different ecosystem to support the production of these parts. So by concluding, let's say, we've made this long path for titanium aluminide blades, for instance, and we are about to launch the production in Cameri in Italy. The production is linked to the 9X engine that is trusting the 777 aircraft. This is the biggest engine ever made, with those blades that are the biggest one ever produced. So you can see the blades over there. This is the first flight of the engine that took last year. As you can see, this is a 747, and the biggest engine is the new 777. So for us that has worked on this project more than 10 years, it's a special moment when we have the first flight of the engine, because represent the let's say, a really important milestone for our career. It's also get back safe. That is also important. And I want to conclude, let's say, with our motto, let's say, in G Aviation. So G Aviation, we invent the future of flight, lift people up, and bring them home safely. I think this slogan is really linked well with additive, because we think we are pioneer in this technology, and as me, we also like to develop our career on this field, because we believe this is really interesting technology for the future. But let's say our priority number one is safety in the aeronautic field. So we have not to forget before putting a new part made by an additive on our engine to make the process robust enough to be safe. And that's the reason why we take more than 10 years to get these blades on the engine. Okay, thank you very much.